Hi everyone, in this video we're going deeper into Docker images and understanding how they work internally. We'll learn how Docker builds images, how layers work, how tags help organize versions, and how Docker caching improves build performance. These concepts are essential for writing optimized Docker files and building efficient container workflows in real DevOps environments. Let's get started. Now let's continue from where we left off in the previous tutorial. Here we have our Docker file. This file contains all the instructions Docker uses to build the image for our application. Now let's open the terminal and explore what is happening behind the scenes. First, let's check the running containers using Docker PS. Here we can see our running container. We can see the container ID, the image being used, the status, and the port mapping between the local machine and the container. Notice that this container was created from the My First App image. But containers are created from Docker images. So now let's look at the images available on the local machine using Docker images. Here, the first column shows the repository name. This is basically the image name we assigned during the build process. Next, we have the tag. Notice that our image is currently using the latest tag. Docker automatically assigns the latest tag when we build an image without specifying a custom version. Then we have the image ID. This is the unique identifier Docker uses internally for the image. And finally, we can see the image size, which represents how much disk space the image is using locally. Now let's create our own custom tag. This is very useful because tags help us manage different versions of Docker images. For example, we can have version 1, version 2, development versions, or production versions. Now let's build the image again, but this time using the tag v1. Once the build finishes, let's run Docker images again. Now we can see that the repository name is still the same, but the image now has a custom tag called v1. This makes it much easier to organize and manage image versions in real DevOps environments. Now that we understand repositories and tags, let's talk about one of the most important Docker concepts, layers and caching. Every instruction inside a Docker file creates a separate layer. Docker stores these layers and tries to reuse them whenever possible. This process is called caching, and it helps make builds much faster and more efficient. This diagram helps us understand how Docker images are built using layers. Docker starts from the base image at the bottom. In our case, the first layer is the Node.js image defined in the from instruction. Then every new instruction in the Docker file creates another layer on top of the previous one. For example, workdir creates a layer. Copy creates another layer by copying the application files. Run npm install creates another layer containing the installed dependencies. And finally, cmd creates a layer that defines how the application starts. Docker stores all these layers separately. That is very important because if only one part changes, Docker can reuse the other existing layers instead of rebuilding everything again. This is exactly what makes Docker builds faster and more efficient through caching. Now let's execute the same Docker build command again to build version 1 of the image. This time, pay attention to the output generated by Docker during the build process. Docker will go through each instruction in the Docker file step by step. But since we already built this image before and nothing changed in the project, Docker will try to reuse existing layers instead of rebuilding everything from scratch. This process is called caching. Caching helps Docker make builds much faster and more efficient. Here inside Docker Desktop, we can actually see the image layers visually. Notice that Docker stores the image as multiple separate layers. Each instruction from the Docker file creates a new layer. For example, we can see the workdir layer, the copy layer, and the npm install layer. Docker keeps these layers independently, which allows it to reuse them later during future builds. This is exactly what makes Docker caching so powerful and efficient. Now let's make a small change to the application. We are updating the response message inside app.js. After changing the file, let's build the image again. Notice that Docker still reuses some cached layers, but the layers affected by the file change need to be rebuilt. This is one of the biggest advantages of Docker layers. Now let's look at the images available on the local machine again. Notice that we now have multiple versions of the same image. Here we can see version 1, version 2, and the latest tag. Even though the repository name is the same, each tag represents a different image version. Now let's run version 2 of the application. This version includes the modification we made inside app.js. Some of these flags were already explained in the previous tutorial, but let's quickly review them again. First, we have the -d flag. The -d flag stands for detached mode. This means the container will run in the background instead of taking control of the terminal window. Next, we have the -p flag. The -p flag is used for port mapping between the local machine and the container. On the left side, we define the local port. On the right side, we define the container port where the application is running internally. And finally, we specify the exact image version we want Docker to execute, which in this case is version 2. Now let's open the browser and compare both application versions running at the same time. On port 3000, we still have version 1 of the application running, and on port 3001, we now have version 2 running with the updated message. This is a very powerful concept because Docker allows us to run multiple versions of the same application simultaneously using different containers and port mappings. And this is exactly why image tags are so useful in real DevOps environments. And that's it for this video. Today we learned how Docker images work internally using layers, tags, and caching. We also saw how Docker can reuse layers to speed up the build process and how different image versions can run at the same time using separate containers. These concepts are extremely important because they are part of real-world DevOps and container workflows. In the next video, we'll continue exploring Docker step by step. Thanks for watching and see you in the next video.